So, normally you want to make a generator, you grab yourself a motor. This is a universal motor, and this, which is from a hoverboard, is a brushless DC motor. Which is okay, because that's the way the bulk of generators are actually made. But there are conditions, for example, in a missile or a rocket, where the conditions are just so harsh that that kind of generator, well, it won't cut the mustard. And there are other times, for instance, you need a very high frequency, high power. A generator like that just couldn't keep up with it. But there are alternatives, and it might be worth looking at those alternatives to see what we might be able to do with this kind of generator. Now in this one, when you spin it, what you're doing is you're spinning the magnets around some coils. In this one, when you spin it, what you do is spinning some coils within a magnet, because the magnets are on the outside and here the magnets are on the inside, so to speak. But either you spin the magnets or you spin the coils through the magnetic field, and then your motor becomes a generator, because of course generators and motors are electrically equivalent machines. But you have to spin one or the other. So I wanted to show you this. This is a coil from a fan. This is pulled from a microwave as it happens, and it's that coil there. I pulled it out, stuck it there, and then I've put some magnets on the back of that coil. So now, both the magnets and the coil are stationary, and of course they're glued to this board, so they're not going anywhere. What I've got here is a bit of steel. If I move that steel, like that LED, well, that means obviously is we're generating, and we're generating something without moving either the coils or the magnet. Personally, I find that a little bit mind-blowing, because I'm used to thinking of moving the magnetic field, and moving the magnetic field I'm used to thinking of it as spinning the coils or spinning the magnets, because motion is relative. Here we're moving the magnetic field in a completely different way. We're actually using the property of the magnet. The magnet wants to find the least path of resistance. It wants to go through something it can go through. Now it's going through this steel at the centre of here, and it's kind of spreading out in the air. The minute I do that, all that rushes up here, because this is the path of least reluctance. Reluctance is that property of magnetism where it wants to follow the path of the least reluctance in the same way that electricity follows the path of least resistance. So it'll go in and out of that steel as I move the steel off and on that piece of iron. And of course what we're doing then is we're forcing the magnetic field to move without moving the magnet. That's very cool. This switched reluctance, which is what it is, we're varying the reluctance and switching it by moving it. That variable reluctance can be used as a generator, and indeed it has been used as a generator. The first generator designed for this was in 1904, and it was called the Alexanderson generator. It came in huge kilowattage, kind of like 5 kilowatts, 100 kilowatts, massive really, and they used it for generating radio frequency, because the frequency is dependent on how quickly I do that. Now I've got this on a rectifier right there, so we're getting DC out, but it was used to generate high power radio frequency until about the 1920s or so, when it was overtaken. Using a lump of steel against that iron core, because it's really easy to demonstrate, but the Alexanderson generator had a huge rotor made out of steel with slots cut in it, and those slots acted the same way as this little bit of steel that I'm using. And you're able to switch that flux, or find the path of least reluctance, and then generate from it. Now this is not a curiosity, this is something we actually use even now. So it was used in the 1900s as a method of generation, and it's used now. This idea is also used in the makeup of guitar pickups. When the string or steel string vibrates across that iron core, it generates, and of course that generation is then picked up and amplified, and that's how guitar pickups work. Now, Alexanderson was a Swedish engineer, and he's really quite famous, so much so that there is in fact an Alexanderson Day in Sweden. It's on the last Sunday of June or the first Sunday of July, whichever is nearest to the 2nd of July. It's actually the predominant power supply for missiles. And the reason it's the predominant power supply for missiles, like the Sparrow and that kind of thing, is it's incredibly robust. Because of course what you've got is a rotor of just slotted steel. There's nothing on it. There's no need for slip rings, there's no need for coils. You just make that rotor out of slotted steel, put it in some bearings and spin it. Now, obviously it produces very high frequency if spun at very high speeds, and that's why it was used for radio. When they put it into a missile, then they power it one of two ways. Either it has its own gas power supply, or quite often it's used for a tiny bit of exhaust is jetted over a turbine, and then that is used to spin that wheel. So how is that useful to us? Well, there's a number of things that I can suggest. One is the simplicity of construction. Obviously it's best used at high speed because speed is a factor, remember. So it's strength of magnetic field, turns of wire that's been cut by that magnetic field, and then the speed at which that happens. So a turbine is a brilliant application for this. So you would get an incredibly rugged device driven directly by a turbine that could produce huge amounts of power that you can make simply. All of those things just seem like massive pluses to me. So I wanted to introduce this idea of switching the flux. And then the thing has been used and is still used and is relatively, in these terms, easy to do. And it uses something we don't often consider. That is, changing the path of the magnetic field so it cuts through this coil is equivalent to rotating the magnetic field. What we need is a changing magnetic field. We can create that changing magnetic field either by rotating the magnets, rotating the coils, or in this case, giving the field somewhere else to go. We're bending that magnetic field, which I really like. So anyway, I thought I would introduce this idea to you of switching the reluctance, or if you like, switching the flux, and this idea of a flux switching alternator that has been used over time. I hope you enjoyed the video, I hope you found it interesting, and thank you very much for watching.